past few days we've gone through how to graph circles, parabolas, ellipses, and hyperbolas. And we dealt with them when the center of them was at the origin. And our equations were for a circle, x squared plus y squared equals r squared, and the radius is r. When you had a parabola, it all depended. X squared, it could equal 4py, or y squared could equal 4px. If it was x squared, then it was up or a down parabola, and if it was y squared, it was left or a right parabola. P represented the distance to the focus point, and the opposite of P is the distance to the directrix, which is a line. When it was an up or down type of parabola, the line was a horizontal line, so it was y equals. When it was a left or right parabola, the line was a vertical line, so it was x equals. Then there was an ellipse, and in an ellipse, you have either x squared over a squared plus y squared over b squared equals 1, or x squared over b squared plus y squared over a squared equals 1. A is the distance to the vertices, B is the distance to the covertices, and C is the distance to the focus points, or foci. And to find the value of C, you had to take a squared and subtract b squared. Now, how did you know which one was A and which one was B? Well, A was the bigger value between the two things that are underneath the x and y. And then there's the hyperbola. And in the hyperbola, it was x squared over a squared minus y squared over b squared equals 1, or y squared over a squared minus x squared over b squared equals 1. In the first case, if x squared was the positive part, then it was a left and right hyperbola. And if y squared was the positive part, then it was an up and down hyperbola. And a is still the distance to the vertices, just like it is with an ellipse. B you really don't need to know, other than, well, you do need to know B, but it doesn't give you the distance to anything that you need for your graph. C is the distance to the focus points, or the foci. To find C, you take c squared, and that equals a squared plus b squared, kind of like the Pythagorean theorem. And then the asymptotes, or the slopes of the lines, would be the y part, a value or b value, over the x part, a value or b value. Now, how did you know which was which? Well, in a hyperbola, the a part is the positive one, which is bigger than the negative one, which is bigger than b. And so those were the four different types of equations. Well, now we're going to move these equations all throughout the coordinate plane. So we no longer will have a center at 0, 0. What that does for your graph only changes a few things. It's going to change what is written here and here, and there. Or on an ellipse, it would be those two things that possibly could change. And here, it could be those things, and here it could be those things. So it's only changing what's with x and what's with y. How does it change it? Well, it depends on where the center is located. But then all of the other things apply to what you have. So let's look at some things. So here's some examples of equations that you might see. Now, we're only going to be dealing with things, graphs that on your coordinate plane, they're like up and down. If it's a hyperbola, or if it's an ellipse, it could be an up and down one like this. We're not going to have things that are angled like so, or having a parabola that goes like that. And for that to happen, there'd have to be another term in here that is xy. That's for a future course that you may take. So we're not going to worry about anything without that. So in looking at these, take a moment and figure out which do you think is which. So in all of these, the circle would be this one right here. The ellipse would be this one right here. The hyperbola would be that one there, and this one is the parabola. Now, how do you tell the difference between them? Well, in a parabola, there's only a squared term, either x is squared or y is squared. They can't be both, because a parabola only has one of the things squared. Then a hyperbola is the next one that we're going to look at as far as what it is. It has both squared terms, just like the ellipse has both squared terms, and the circle does. But in a hyperbola, one of the squared terms is positive, and one of them is negative. In an ellipse, both of them are the same, and as far as positive, and same with a circle. The difference between a circle and an ellipse is the coefficient in a circle has to be the same number, whereas in an ellipse, they have to be different numbers. It does not matter what these values are. Only the squared terms. So that's your first little lesson. So now how do we write this circle that has a center at 2, -5 and the radius is 6? It is a circle. So therefore we're dealing with x squared plus y squared equals r squared. It tells us the radius is 6, so therefore we know that r equals 6, and that will be 36. And then since our center is 2, -5 on our graph, 2, -5 is right there, and then our radius is 6, so it's going like so. So we have to take the x value, and just like with everything we've done so far this year, it becomes x minus 2 plus, and then y plus 5 squared. And there's the equation of a circle with a center at 2, -5 and a radius of 6. Then an ellipse with vertices at 5, -3, and 5, 5. So if we're looking at this graphically, we have vertices at 5, -3, and 5, 5. And then we have foci, or focus points, at 5, -1, and 5, 2. So now we're dealing with an ellipse. So this is x squared plus y squared equals 1, and then it's a squared and b squared, or it's b squared and a squared, like so. Now because we have vertices at these 2 points, and here are the focus points, then our ellipse has to be something like this. It has to be taller than it is wide. So therefore, the value of a has to be underneath so this one is b squared and that one is a squared. And a is the distance from the center to a vertice. Well, we better find the center first. And if this is 5, 5, and that is 5, -3, halfway in between a -3 and a positive 5 is 1. So our center is at 5, 1. And that would make our equation x minus 5 squared plus y minus 1 squared equals 1. And now we know then the distance from A, that distance right there, is 4, which makes this 16, 4 squared. We know the distance from here to there is 2, which is the value of C. So now we have to figure out what is B. And because this is an ellipse, A squared minus B squared equals C squared. So substituting in the values we know, so 4 squared is 16 minus B squared equals 4. Subtract 16 from both sides, and you will get negative B squared equals a negative 12. Divide by a negative 1, and B squared equals 12. Well, now we really don't have to go any further than that because we're supposed to put it over B squared. So that is 12. If we were to figure out the value of B, that would be the square root of 12, which is roughly 3 point something. But we want to write it over B squared. And so here's the equation of our ellipse. All right, now we have a parabola with a focus at 8, negative 7, and a directrix at x equals 3. Well, that gives us some different things. So 8, negative 7, that is our focus point. And our directrix is at x equals 3. 3. That is our line for our directrix, which means the center of our parabola, or the vertex of a parabola, has to be halfway in between here and there. Well, if this is 3 and that is 8, halfway in between 3 and 8 is 5.5, comma, negative 7. And our parabola is going to be going like this. And since it is opening to the right, that is a y squared equals 4px type of parabola. So we can say then the y is y plus 7 squared, and then we would have x minus 5.5. Now we have to figure out what is the value of p. Well, p is the distance from here to there, or from there to there. And that is going to be 2.5. Because of 5.5 plus 2.5 is 8. So then 4 times 2.5 is equal to 10. And so our equation is y plus 7 squared equals 10 times x minus 5.5. Moving on to a hyperbola. Vertices at 2, negative 5, 4, negative 5. So 2, negative 5, 4, negative 5 are the vertices, and the foci are at a negative 3, negative 5, and 9, negative 5. So because these are the focus points, and these are the, or no, these are the focus points, and here are your vertices, our hyperbola has to be doing something like this. So it's a left and right opening hyperbola, which means that x squared minus y squared equals 1 in a squared and b squared. And so now we got to figure out everything. Well, first let's find the center. The center has to be halfway in between the vertices, or it's halfway in between the foci. Should be in the same place. Since these are both -5, we need to figure out what's halfway in between 2 and 4. 2 plus 4 divided by 2 is 3. Well, that should work for this as well. For -3 and 9, -3 plus 9 divided by 2 is also 3. So our center is at 3, -5. That takes us to x minus 3 squared and y plus 5 squared. And now we know that the distance from here to there and there to there is 1. So therefore, this will be 1 squared, which is 1. The distance from here to here is 6 on both of those. So that's telling us then that the value of A is equal to 1, the value of C is equal to 6. We have to figure out what is the value of B. Well, to do that in a hyperbola, we know that A squared plus B squared equals C squared. And so substituting the values in, 1 squared is 1 plus B squared equals 36. So then subtract 1 and B squared equals 35. And that means that B would be the square root of 35, so it's 5 point something. But when we write B squared, so therefore it is going to be 35 right there. That makes our asymptotes have slopes of the square root of 35 over 1. So then that's actually, my drawing should be more along the lines of this, since the slopes are almost like 6 and a -6 through that point. Okay. Now then, one other part to this lesson is to deal with an equation like one of these. How in the heck do we figure out how to graph that? Well, yeah, you can put it into graphing utilities, but you also have to be able to write it and figure things out. So here's where we did this back when we had quadratic equations and we had to complete the square. So to do that, the first thing you do is subtract 90, so you get -90 on the other side. Now you can divide this side by 2 and that side by 2 as one method for doing this, but when we get into this, you're going to have more than one thing that you're going to end up having to do with that part. So rather than divide by 2, we will factor a 2 out of this. And then that turns into x squared plus 8x equals a -90, and then that number doesn't change. So now we have to try to complete the square. And that's staying a 2 there, and this becomes x plus 4 squared. And the value we have to add here in order for that to become a perfect square is 16, because that's what 4 squared is. And now, since we added 16 here, we have to add not 16 over here. And the reason we are not adding 16 over there is because of this 2 on the outside of it. So you have to take 2 times 16, which is going to be 32. And then that will equal a -58. And then you can go from there to finish it all. So that's the process you're going to end up having to do with the rest of these, except sometimes you're going to have to do it twice. So let's look at this. First off, we are looking at a parabola. And by our rules of parabolas, it's either y squared equals 4px or x squared equals 4py. Now, we have a y squared here, so therefore, we are dealing with this one, which means we want the y squareds on one side and the x stuff on the other. So we will keep y squared minus 2y together, and we will add 4x and subtract 9 to get 4x minus 9 over here. Now we have to complete the square. So half of 2 is 1, so it's y minus 1. In order for us to write this as a factor squared, we would have to add 1 to that because 1 squared is 1. And if we add 1 to the left side, we must add 1 to the right side, which that then equals 4x minus 8. Now, we do not have this in proper form yet in order to find things because this is not 4p times x in parentheses of something. So we have to get it that way. So you want to get the coefficient of x to be 1, so we're going to factor a 4 out. And when you divide this by 4, you would get x minus 2 equals y minus 1 squared. Well, now we know then we have a center at 2, 1, and the value of p is equal to 1. And since it is y squared, it's going like this. Since this is a positive 1, this coordinate right there is 2, 1, and the focus is 1 away, so that makes it at 3, 1, and the directrix is on this side 1 away, which makes that x equals 1. All right, hopefully you followed all that. Now we're looking at, well, we have two squared terms, and that's a 2 and that's a 1, so therefore, and it's a plus in between, not a hyperbola. So it's either in a circle or an ellipse, and since these values are not the same, it is an ellipse. So in an ellipse, we have x squared plus y squared. A and b equals 1, well, a squared and b squared. Or b squared and a squared, depending. We're not going to know for sure until we actually get it into the proper form. So we want to group the x's together. So 2x squared minus 4x plus y squared equals 4. Because we want to move that to the other side. So now in order to complete the square, we first have to get the coefficients for the squared terms to be 1 by factoring out whatever is there. So 2 and x squared minus 2x. This one there's nothing to do, so that's kind of sweet when you have a problem like that. And so now to complete the square here, we have 2 times x minus 1 squared, which means we had to add 1 to that because 1 squared is 1. But we actually have to add 2 to this side because 1 times 2 is 2 plus y squared equals 6. Had nothing to do with that one. And so now, to get it into the correct form, we have to divide both sides by 6. And so our final equation is going to be x minus 1 squared over 3 plus y squared over 6 equals 1. And so now we know the center is at 1, 0 because of that, and there's nothing there. The value of a is equal to the square root of 6, because that's the bigger number. The value of b is equal to the square root of 3, because it's the smaller number. And the value of c is equal to the square root of 3 also, because you take 6 minus 3 and the square root of that, because a squared minus b squared equals c squared. And so if we were to sketch a graph of this thing, we would have 1, 0 as our center. The value of a is the square root of 6, which means it's like 2 point something to the up and down action, and square root of 3 left and right, which is 1 point something. And there's your ellipse, and those values would be in there somewhere because they're up and down the square root of 3. And now we'll look at one more, and this happens to be a hyperbola, because we have a 4 and a negative and a 9. So again, we have to group the x stuff. 4x squared plus 32x, negative 9y squared minus 144y equals 548. Then we need to factor the 4 out to get x squared plus 8x. Here we factor a negative 9 out to get y squared minus, no, plus 16y equals 548. All right, now we complete the square. So this is going to be 4 times, and half of 8 is x plus 4 squared, which means we had to add 16. And 4 times 16 is adding 64 to that side. And on this one, we have a negative 9 times y plus 8 squared, which means we had to add 64. And so since that is 64, what you have to add to the other side is 9 times 64, which is 576, but we're not going to add because this is not a positive 9. It is a negative 9, so we are going to subtract 576. That comes from a negative 9 times 64. And when you combine all of that together, you are going to get 36. And then finally, our last thing is divide by 36. And we will be left with x plus 4 squared over 9 minus y plus 8 squared over 4 equals 1. And so our center is at negative 4, negative 8. The value of a is equal to 3. The value of b is equal to 2. And the value of c is equal to square root of 97. Because you take 9 squared plus 4 squared. And so if we were going to sketch a fine graph of this thing, center is negative 4, negative 8. And then we know the value of a is 3, and this because it's x plus 4 squared is the positive part. We're this type of hyperbola. So the vertices are 3 from there, which would be right there and right there. And then we know that the slopes of the asymptotes are going to be 2/3, plus and minus. So then from this point right here, we would go up 2 and over 3, up 2 and over 3, or down 2 and over 3. And there, and there. And our focus points are the square root of 97, which is like 9.8. So from the center, so you got to do 9.8 that way and 9.8 this way. So those coordinates would be at -4 plus square root of 97 comma -8, and a -4 minus the square root of 97 comma -8. And then these points here would be 3 from there, so at a -1 -8 and a -7 -8. And then your hyperbola would be going like so. And I know that's a lot of information, so take your time working on some of the problems in this section. And hopefully you have a good understanding of it by the time you're done with that work. If not, ask me some questions.